In this module, we're going to continue exploring properties of functions and how to define and use them in Python. Functions are what are called first-class objects, and the characteristics of what a first-class object is described here. But the main point is a function is just like any other object in Python, like an integer, float, a string, a list, etc. So the result is we can assign a function to a variable. We can pass functions to functions. We can return functions from functions. Functions can be part of a list, a dictionary, a set, etc. And here are links to defining functions from the Python tutorial and more details on defining functions from the Python tutorial. Okay, so let's explore this by defining a factorial function. And here I'm going to provide two different formats for defining the function, and have to confess that the first form I'm not as familiar with, and I'm showing it for completeness and for my own education. So here, so a factorial is a function that returns the product of the numbers between 1 and n. So in the first case, we're passing a function n, and we do an if statement. So we're going to return 1 if n is less than 2. Else, we're going to return n times the product, n times factorial of n minus 1. So here you see we're going to have a recursive function call. And the second definition is essentially the same way, but it has a different construction of the if-else. So like I said, a function is a type, like integers or strings or integers. So if we do the type, it's going to tell us it's a type function. And since functions are objects, they have attributes and methods. And we can explore what these are using either our dot tab in IPython. There's a built-in function dir, which will tell us what the pieces of that object are, or there's an inspect module in Python that provides functions for us to explore these in more detail. So here if I take factorial and I do the dot, these are all the different attributes that come with the function. So see, it has an attribute function name. Let's see what else we have in here. Code. So that's a code object. Let's see if we, oh, it's not callable. Okay. So, oops, whoa. We shouldn't have any defaults because we don't have any defaults defined for this. Okay, so let's, we can also do the dot tab to see what are referred to as hidden or magic functions. So this has an attribute call. If we do the code here, so that's another code object. Doesn't work. Here's the docs associated with it. So that's our doc string, etc. We can call dir, and this returns all the attributes and methods of the function. And we can use the inspect.getSource. There's other functions, but this actually shows us the string that defines the code that we're working with. Okay, because functions are objects, we can assign them to variables. So here I'm creating a variable func1, and I'm assigning to it factorial. And then this variable can then be used just like the original function, so I can call it. And if we just want to compare we're getting the same thing. And if I do, I see that it's referring to the same object. Okay. So here are different ways that we can test whether what kind of object our function is. So here I can invoke the isAnInstance. In this case, I'm taking a NumPy function, the exponent function, and seeing is this a type of a NumPy U function. I'm not sure what why it's a U function. I'm going to see if function 1 is of type function type, and then I'm going to test whether func1 is callable. That means I can use it as a function, and this is equivalent to calling the hasAttribute method, and I'm asking does it have an attribute method called call double underscore, and that's how Python calls things. So here you can see in all those cases it's true. Okay, so let's define a function that has a function as an argument. Okay, so this is a plot function. So it's going to take as a argument a function f, and then I'm providing ranges over which I'm going to plot it. I'm going to create a NumPy array of x values, and I'm going to test to see if what I pass in is actually a function, whether it's callable. And if it is, then I'm going to plot x versus f of x. If it's not callable, then I'm going to give a message saying that it's not callable. Okay, so that's taking a function as an argument. We can also create functions that return arguments. So in this case, I've defined a function get NumPy function, which I pass in a string, which will be a name of a function. And then what I'm going to do is I'm going to return the NumPy function corresponding to that name. And I'm going to get that function from the NumPy module with the getAttribute function. And I'm going to test to see if it's callable. If it is, then I'm going to return it. If it's not callable, then I'm going to print a message that it's not a function and return as a default absolute value. Okay, now let's glue these together. So I'm going to create a function called get and plot, where it's going to take as a positional argument a name, which I'll type in the name of a function, and then as keyword arguments, these parameters that I'm going to use to generate my x values. So then I'm going to take this name string, I'm going to pass it to get NumPy function. So then that returns the function f. And I'm going to take that function f and I'm going to pass it to the plot function like so. Okay, and so I can demonstrate that here where I passed in this is just the string cosine and these keyword parameters, and I get the plot of my cosine function. Well, we can work this out with the interact. Let's see, so maybe make my step size a little smaller to make it smoother. And I can just type in different function names. Change my range. Oops. Let's do like a -2 to 2, say. There we go. That step size a little smaller. Okay. So here we've demonstrated creating functions that take functions as arguments and functions that return functions. Those are referred to as higher order functions. So functions that take functions as an argument or functions that return arguments are called higher order functions. Plain old functions, like we'd have been exploring previously, are called first order functions. Okay, so now let's talk about making our code our functions more robust. In that, what if the user passes something to the function that's what you're not expecting, or you're getting results that you're not expecting? So the first approach might be to program in tests. And so here I'm going to write a function that's going to take a string and parse temperature. So we're going to assume that's very similar to what, the same thing we did in class previously. Takes a string s and extracts a value and a unit, assuming that we entered it as a numeric value followed by the last character in the string being the unit. So the question here is, so what if they didn't enter a number? So how about providing a flag value? So here we're using slicing to get the value and to get the unit. I don't really want that print statement in there. Oops. Do that. So I'm going to check and see if value is a digit. If it's not, then I'm going to return some default value, -999, that my calling function may have some logic to deal with it, knowing that this isn't a real value. Else I'm going to convert it to a float and return it. Okay, so what happens if we pass in 101.3? Well, we're getting -999, and that's because our 101.3 isn't a digit because it has that punctuation character in there. So the is-digit test for our temperature input. So, okay, let's try this, and well, I can get rid of that period for the sake of testing whether the rest of the values entered are digits. And let's see what happens here. Now I'm going to enter -101.3. Okay, well this is getting -999 again, and that's because, well, I have this negative symbol here. Well, okay, I can strip that out and keep doing the test the same way. Okay, now it worked. But you can see that kind of anticipating all the different options that someone might enter, etc., can be a combinatoric problem, and this can become very complex. So there's a more general approach to this, and this is through using exceptions. And exceptions, and I've got links here to things in the Python documentation. Exceptions are another basic Python type, and we're going to use exceptions to deal with unexpected or unwanted behavior in a function. Okay, so bringing up our Greek myths, and I think since I'm recording this on Groundhog Day, and I just turned on the movie with Bill Murray and Ally McDowell, that the thing here is you're going to try until you get it right. Okay, so